Okay, we're back, banging, and slamming. We are here to look at codes today. We're going to look at codes and what are codes. Codes basically are representations. Okay, code to encode something is to represent something. All right, so what are we going to represent? Our computers basically use codes to represent the various characters. I'm looking at the keyboard right now and I'm seeing all these characters, the letters, whatever else, the end, the star, and what asterisk, whatever else that you have there, the numbers. So codes are basically representations of what of our characters and numbers. All right, so now it's not sufficient to say only characters, even numbers. If I have a number 7 and I input it into a computer, the computer will change that into a code that it understands properly, depending on the on the program that I intend to run. So it will, whatever, each program will have its own its language. Therefore that language is actually a code that the computer will use, the microprocessor of the computer will use to actually work with whatever characters and whatever you want to work with. Now what we then do is say we are going to classify these codes into what? Into numeric codes. And okay, I'm supposed to have a pen. All right, we are going to have a numeric or numerical codes, and we are going to have what? We are going to have alphanumeric codes. What's the difference? Alphanumeric. All right, the numerical codes are simply going to use what? Are simply going to use numbers, digits. All right. The alphanumeric codes, on the other hand, are going to mix the alphabet and the what? And the numbers. So now, if you look at these numerical codes, they can be classified as either weighted codes. I will not. There are so many. I will mention a few. There is the 8421 BCD. There is the 2421 BCD. Well, I don't know why I skipped a few codes that we've looked at already. Binary is a code, unfortunately, it can only cater for what? For two things, 0 and 1, the on and off. All right, it's a code for on and off. So the very first one that I probably should have mentioned here is actually what? Binary itself, because it is a code. All right, so I'll come and say I should have said binary. We can represent any number in binary, so we can encode anything into binary. So binary is the first code where everything is put into ones and zeros, into sets of ones and zeros, right? The 9 will be changed into 1001. Okay, so it's the very first code that we did was what? When we looked at binary. When we looked at what? Octal, that's a code as well. Okay, that's a code using what? Using numbers, not only ones and zeros. It uses what? The numerals from 0 up to what? Up to 7. Octal was also a code. Now we cannot, however, we cannot put the what? We cannot put the someone will say, okay, by the way, we did binary, we did octal. Then someone can run off now and say no, but we also have what? We also have hexadecimal. No, hexadecimal is actually what? It's actually an alphanumeric code. Why? It's got to remember from 10 up to 15. It uses the letters A up to F. So there's alphabet 0 up to 9, and therefore hexadecimal falls, yes, under codes, but it falls under what? Under alphanumeric codes. All right. Going back to the what? Going back to the what call this? To the weighted numerical codes. We will have something like, we have so many of them. We have a 5221, for instance. Okay, let's start with the 4. Let me start with the 4221. There are many. There is the 5221. And they are all binary coded decimals, these ones here. We've got the 7, 4, bar 2, bar 1, BCD. I'm tired of writing BCD. I'll probably use. Then we've got the 8421. Okay. And it's also BCD. All right. If there's anything else that I didn't mention there, there isn't anything that is amazing. But then I'll come back and say, have we looked at things so far? We have looked at another code that we've looked at was the what? It's a code. We must mention it. Let me borrow the hand, and I'll mention the pen again. We did the Hamming code, but is the Hamming code weighted? Okay, the Hamming code is not weighted. So we'll come and say we have weighted codes, but then we also have non-weighted codes. And under these, we will have stuff like XS3, excessive 3. This excessive 3, all right. We've got stuff like XS3. We've got stuff like the gray code. Okay. We've got stuff like the Hamming code. That is a code. Okay. The Hamming code. We've got, if I didn't mention anything, it's probably because there are so many codes. There are so many codes, all right. But I think since we've covered some of these, or we're still going to cover some of these, I might as well mention them, all right. So codes can also be classified as either numerical or alphanumeric. Codes can also be classified, the numerical codes can be classified as what? As weighted and non-weighted. Then codes, generally, all the codes can also be what? Can also be classified as what? As what you call it? Complementing, self-complementing, or non-self-complementing. Okay, so codes not. Codes can, the numerical codes actually can also be classified as as non or self-complementing. All right, I'll put it in one thing. Self-complementing. This is for the numerical codes. They can either be self-complementing or non-self-complementing. All right. I'll come back to this. So I'll come back later also to the what? To the alphanumeric codes, because among those alphanumeric codes here, we can count what? We can count also the ASCII code is very what? Okay. We've got the other code. It's called the extended binary coded decimal for information interchange. I think it's information. No, extended binary coded decimal interchange code. Okay. This can also, it is an extended version. This is there's an extended version to this. Okay, we've got different versions of this particular code. All right, we've got other codes. We've got recently, back in the day, they couldn't what? They couldn't. The codes were limited. We didn't have emojis and stuff. Emojis are stuff that just came in now. There are some characters. There are some pictures now. You can send what call this GIFs. So that GIF content also has their own what? They also have their own code. There's this new code that is called. I'll come back to it because I don't want to lose my line of thought. I'll come back to another code. There's a code that I'm going to add there, but I don't want to lose my line of thought and end up making my recording a bit too excessive. Now, but I know that the ones that I'll cover in the context of the syllabus that I'm teaching now, I think I've covered everything that I need. All right. So now, if you look at these codes now, let's dissect a few of them. Let's say, for instance, I were to say, let me bring this down a little. I'm not happy with the distance there. I'm gonna bring this, or the just came up to my mind as I'm thinking about moving this. We have our latest code, the Unicode. A very important code. This is the current code. Otherwise, the rest of them are becoming out of fashion. I mean, who's really going to want to use a code that cannot take care of emojis? I mean, every time we type these days, emojis are the first thing that springs to mind. All right. So now, I wanted to move this down. When I remembered my code, I wanted to move this down. All right, so that I can move the page a little bit up. I need to work on some of these numeric codes. What I'm going to do here, I'm going to come back with the 8421. BCD is a binary coded, so these are all decimal codes. These are all decimals. Binary coded decimal, binary coded decimal, binary coded decimal. Okay, those are versions of binary of what? These are binary codes, binary and octal, and the hexadecimal, and then most of these are actually, these are binary codes. These are binary codes, ones and zeros. Now these ones here are actually decimals, yes, but they are what? they are decimals that are made to look like what? That at first thing you may actually what? You may instinctively call binary, because they look, when you see them, it's bunches of ones and zeros, so you may assume it's actually binary. So I don't want to keep saying BCD. Let's just know that everything here is BCD. So I will not keep saying BCD. I will now come and say, how about the 2421? Remember, it's all BCD. 2421. I want to try and do all of them once in the table. Okay, and then 5221, the 74 bar 2 bar 1, the 84 bar 2 bar 1. Now these are decimals, therefore they must represent the decimal symbols of 0, 1. Let me have des here. Okay, now this 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I think I can move a little bit up. I don't need much. So then I could say for 8421, all you do is all these here are going to be split into what? Into 4 bits, and they are going to be, look, these are weighted codes. So if I have, do I have anything on 8? No. Nothing on 4, nothing on that. For what? For the 0. For the 1 that sits in the last position has a weight of 1. The 2, the bit that sits in this position is a weight of 2. The 3, since this is a weight of 2 and a weight of 1, together they make 3. The 4, there is a weight 4, so we are going to use that. The 5, we have to make up 4, we need a weight of 4 and a weight of 1, so that's the 5. The 6 is the 4 and the 2, the other weights. Okay, the 7, we need what? We need the 4, the 2, and the 1. The 8 is the 8, and the 9 is the 9. All right. 2421 works more or less similarly, but let's see. 0 cannot have any weight. These are weighted codes. Cannot carry any weight. There's no weight of 0 here. If it was 2421 0, maybe there would be a 1 on the 0. We don't have a thing, so we've got nothing on them. Then the 2. Now we've got 2 2s. So the 2421, all these codes that have 2 2s, that have more than 1 2, for numbers that are less than what? For decimals that are less than 5. For numbers that are less than 5. Not for numbers that are less than 5. We use the what? The lower order 2. Remember, the order starts here. This is what? This is 2 to the power of 0. This is 2 to the power of 1. So the lower order 2, this is in the position of 3. If it was powers, this would have been power 3, but it doesn't work that way exactly the same. So we just call it lower order in terms of what? Least significant digit being this side and highest significant digit being on the what? On the left. So now the 1 therefore will have a weight of 1. We'll have a 1 on the space of 1. The 2 is not going to be this 2. It is going to be the lower order 2. All right. The 3 is going to be the lower order 2, because 3 is less than 5 with the 1. The 4 is the 4 itself. The 5 is it the 4, because we have 2 possibilities. We've got one possibility with 4 and 1, another possibility with 2, 2 and 1. Remember, for numbers below 5, you use the lower order 2. The numbers above 5, you use the higher order 2. Now 5 itself uses both 2s. Okay, so this is 2, 2 and 1, right? And then the 6 is the higher order 2, because 6 is higher than 5, with the 4, and there we have our 6. The 7 is obviously the higher order 2, the 4 and the 1. The 8 is what? Is the 2, the 4, the 2 is both 2s. Now the 9 is everything. 2 plus 4 plus 2 plus 1 is what? Is 9. Now that is straightforward. Now let's look at something here. If you look at that part, what do you have? You have, if in the case of 0, nothing. In the case of 1, 1 obviously. In the case of 2, the lower order 2 because 2 is less than 5. In the case of 3, the lower order 2 and the 1. In the case of, oh, I'm going to 4. The 4 is the 4. Okay. The 5 is the what? The 2 2s and the 1. The 6 is the higher order 2 and the 4. Okay. The 7 is the higher order 2, 4 and 1. And then the 8 is 1, 2, 3. Okay. And the 9, I'm going to want to move this a little to avoid traffic there. The 9 is going to be all of them. Alright. 5, 2, 2, 1. Okay, this is easy now. I'm just going to fill it up. 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 0, 0, 1, 1, 4, there's 0, 1, 1, 0, 5 is obviously now the 5 itself. Okay, the 5 is the 5 itself, and I'm putting a 0 now. The 6 is the 5 and the 1. The 7 is the 5 and the higher order 2. The 8, higher order 2 and 5 and 1. The 9 is, okay, there can be no extra one, it will be 10 otherwise. Now we look at, what do you call this? The 7 for, what does the bar 2 bar 1 mean? It means subtract. So if I want 0, obviously I don't take anything and I subtract nothing. The 1 is obviously in this case 4 minus 3. The 2 is obviously 4 minus 2. The 3 is obviously 4 minus 1. The 4 is obviously, there are two ways of having 4 here. Alright, how do we get 5 here? 5 is what? Let's start with 5. I want to show you something. The 5 is 7 minus 2. Okay, the 4 and 5, you see that if we do this, I'll explain why that was important. I'll come back to it. Now, let's look at the 6. I'll come back to it when I'm done with 9. The 6 is 7 minus 1. The 7 is obviously 7. The 8 is what? The 8 is 11, 7 and 4 minus 3, 2 and 1. And then what I do, the 8 is 11. Okay, the 9 is there's something a little bit wrong here. Let me just check what's going on. The 9 is supposed to be 7 plus 4, that's 11 minus 1. The 9 is supposed to be 1 that's 11. If I subtract 2, that's supposed to be 9. Now if that's 9, it makes my 0 wrong. Okay, I'll check this. Something's very wrong here. I'll have to check what's going on because this is 11 minus 3 is 8. Okay, then there's no problem. What I was thinking is supposed to happen with what? With this part here. Now I have to come back and say, for the 4, our 4 is supposed to be, when I think of 4, is supposed to be 4 itself, because we have a weight of 4 here. We have a weight of 4. So here what we did was, no, this is wrong, because this is 4, oh God. Here what we did was 4, that's 3. 4 minus 1 is 3. Oh, they look the same even. 3 and 4 look the same. Okay. Alright, sometimes we get carried away. Now, alright, because now I was I miscalculated here. I'll come back and explain why I believe I miscalculated. Then the 5 is what? 7 minus 2 is 5. Yes, 7 minus 2, no, the 5. 7 minus 2 is 5. There's nothing wrong with that. Okay, fine. No, this was something else. All right. I was mistaking this for this code. I'll explain when I'm done, or why I was thinking, I was mixing them up. All that is 0 is 0. 1 is obviously 4 minus 3. I have to be careful now. 2 is 4 minus 2. That's why they look the same. That's why it gets a little bit confusing. Then this is 3. 3 is 4 minus 1. So far they look the same. And then, alright, this is supposed to be 4. We have a 4. Okay. 5 is 8 minus 3. 1 minus 1 on the 8 and 1 on the minus 2 and minus 1. Now the 6 is 8 minus 2, right? 8 minus 2. 7 is 8 minus 1. 8 is 8. 9 is, yes, this is what I was thinking. Now, because why I was a little bit worried here, I thought these two are supposed to complement. I explained self-complementing codes, and I know that I was expecting this to be a self-complementing code, but I had done a little bit of wrong math in my head. Because now, there's this question. This is I'm going to explain what I'm talking about now. This is how do you identify a code that is what? That is weighted, both weighted. That is both weighted and self-complementing. How do you identify that code? Both weighted and self-complementing. Alright, I need to remove a little bit. Self-complementing. It's simple. For the code to be weighted and self-complementing, the sum of the weights must be 9. The sum of the weights must be 9. All right. Let's look at this now. When is a code self-complementing or not? All right. Self-complementing codes, for any given number S, if the code word of S, code word of S of any, okay, the code word of S, which is actually any decimal digit from 0 to 9, the code word of S code word, and should not say this, S code word must be one's complement of 9 minus S. What do I mean? That if two numbers are 9's complement of each other, their code words are going to be 1's complement of each other as well. Right? If two numbers satisfy that condition, that if the numbers themselves are what? Are 1's complement of each other from 0 to 9. The numbers, take an example 2 and 7, take an example 3 and 6. If two numbers are 9's complement of each other, and their code words also happen to be 1's complement of each other, those two numbers are what? That code word, that code is self-complementing. Alright. S code word must be 1's complement of what? Of 9 minus S. Remember, 9 minus S is what? If this is S being what? With S equals to anything from 0 to 9. Right? If S or rather in mathematical we should put it, maybe let's put it more mathematical. Let's put it more mathematical. Okay, with 0 less than or equal to s less than or equal to 9. So s must range from 0 to 9 inclusively, and if that's the case, and then the code word of s is 1's complement of what? Of 9's complement of s, then that code is what? Is self-complementing. S code word must be for code to be self-complementing. Now this does not mean only what? Only weighted codes. Any code. Okay. If in any code for the decimals 0 to 9, if any two numbers are what? Are self-complementing, and their code words are also if any two numbers are 9's complement of each other, specifically 9's complement. To say complementing is a bit misleading because there's 10's complement. If the two numbers are 9's complement of each other, that's why we say 9 minus s. Okay. If any two numbers are 9's complement of each other, and their code words as well are also 1's complement, not complementing, but specifically 1's complement, because there's 2's complement. It does not work for 2's complement. If the numbers are 9's complement of each other and their code words are 1's complement of each other, then that code is what? Is self-complementing. Let's look at this. Is this self-complementing? Looking at the weights, 8 plus 4 is already above 9. No. Is this self-complementing? And then just pick an example. 0 and 9 already are not self-complementing. If these are all zeros, the complement would have been all ones. Right? You can see. Any one example goes wrong, then obviously it doesn't work. Let's look at this one here. Let's look at this one here. This is self-complementing. So this is not self-complementing. The 8421 is not self-complementing. The 5221, the weights add up to 10. Look at 0 and 9, which are complements of each other. The code weights are not complements of each other, so not self-complementing. If you look at 8421, 84 bar 2 bar 1. No. Let's look at 7. That's the mistake I almost made last time. I wanted to say 741. The total here is 11 minus 3. 11 minus 3 is 8, which is not 9. Therefore, the codes are not self-complementing. But let's check. Is 0, the complement of 1's complement of 0 is supposed to be what? To be 1's complement of what? Of what is 9, because 9 and 0 are complements, are 9's complement of each other. So this is not 1's complement of that, so that code is not self-complementing. Let's look at 2421. 2 plus 4 plus 2 plus 1 is 9. Is this self-complementing? Let's see. 0, all zeros, all ones. Yes, complementing. 3 zeros in the 1, 3 ones in the 0. Yes, complementing. 1's complement of each other. 2 zeros, 1 0. 2 ones, 0 1. Yes, complements of each other. Then that's 3 and 6, which are complements. 0 0 1, 1 0. Yes, complements of each other. 4 and 5, which are 9's complements of each other. 0 1 0 1 0 1. Yes, complements of each other. So this code is self-complementing. 4 2 2 1. 0 and 9 are complements, are 9's complement of each other. 0 and all zeros and all ones. Yes, complements. 3 zeros in the 1, 3 ones in the 0. Yes, complements. 2 and 7 are complements. 0 0 1 0, 1 0 1. Yes, complements. 3 and 6 are another pair. 0 0 1, 1 0. Yes, complements. 4 and 5 are the last pair. 1 0 0, 0 1. Yes, complements. So you can see that code is also self-complementing. And then of the examples we've put up here, let's see. This is 12 minus 3, which is 9. So we expect it to be self-complementing. 4 zeros for 0 and 9 are complementing. 4 zeros and 4 ones complementing. Yes. 0 triple 1 for 1 and 8. 1 0 0. Yes, complementing. 0 1 0. 1 0 1. Yes, complementing. 3 and 6. 0 1 0 1. 1 0 1 0. Yes, complementing. 4 and 5. 0 1 0. 1 0 1. Yes, complementing. So you can see it's true that these codes are what? If the weights are 9, then the codes are going to be self-complementing as well. Right? We've looked at a lot of codes. we have the XS3. Let me leave this section here. For what I've done here so far is what I've done so far is let me bring this down a little. Don't seem to be able to bring. Okay, what I could do is move this up a little, because that's where I'm getting the problem. Move this up a little. Okay, and then probably try again to bring that a little bit down. All right, I think that's perfect. Now if I then say, okay, we've looked at numerical codes, we've said that these are codes that only works with what, with numbers, ne? And then we've looked at alphanumeric codes. We've just mentioned alphanumeric codes, and you said what, we've got the what, the hexadecimal, which we've done already. We are going to look at ASCII later. We're going to look at what, the ABC, DIC. Where the Unicode is not really in the context of what we do so far, so we'll probably look at a later stage. The target market right now is not really looking at the Unicode so far. So then we've mentioned the weighted codes. We've said weight codes can be weighted or non-weighted. With examples there of the XS3. I've dealt with weighted codes today. I've shown the binary, octal, and the what, the hexadecimal is weighted, but it's alphanumeric, but it is weighted. And then we look at what, we look at, is it weighted? No. Is the hexadecimal weighted? No, it's alphanumeric. I wouldn't say it's weighted. It is 8421, but when it comes to the A, it is 8421. Yes, it is weighted. Yes, the hexadecimal is weighted. I never really thought about it. I never really thought about that, but yeah, it is weighted. Oh, did I cause a little problem there? I closed away my note. Okay, should move it up without really messing up my note. Okay, now we said also codes can be classified as what, as either non-self-complementing or self-complementing. Now if they're self-complementing, what do you say? We say that what, if they are weighted, some of the weights must be 9 1, but in any event, generally if they're not weighted for any code, if the code is what, if the code is self-complementing, then if the code word of a number must be one's complement of what, of 9's complement of the original number. I think that summarizes. In our next session, what I'm going to look at, I'm going to look at the few 9-weighted codes. I will probably take a look at the what, at the alphanumeric codes one by one. But I'll start with the what, with the 9-weighted codes. I will have a session, a different session on the Hamming code. I'll probably do the XS3 code and the Gray code all in one. So see you later. Enjoy. I had fun. I hope you did as well.